Once you have worked with a lot of different functions and taking their derivative and learning how to work with the rules of differentiation, whether it be the product rule, the quotient rule, the chain rule, term-by-term differentiation, you're ready to get to the part of calculus content that is applications of derivatives. Now, one of the very beginning theorems that we do in our applications of derivatives work is something called the extreme value theorem. So with the extreme value theorem, we have a function that is continuous. So let f of x be a continuous function on a closed interval from a to b. So continuous function, remember, it has to be continuous at all the points in the interval. And for a function to be continuous at a point, its limit has to exist as you approach that value of x. The function has to be defined at that point, and the limiting value has to be the same as the output of the function there. Now, when we're looking at that, there's a lot of different functions that we know are continuous, and we can just say they're that type of a function and then be able to have our continuity and move on from there. Polynomials are continuous everywhere. The sine function and the cosine function are continuous everywhere. Rational functions are continuous at all values that are not going to give you a zero in the denominator of the fraction. So those sorts of things are different types of functions that we can just automatically say that it's continuous. Now, for those sorts of functions that may have spots where they're not continuous, as long as those values of x that have discontinuities are not in our interval, we can still apply the extreme value things. Now, also here, our interval is a closed interval. Closed interval means that it includes the endpoints, and the brackets are what show you that it includes the endpoints. Technically, writing this theorem up, I wouldn't have to necessarily say these words closed interval, because as long as I had that the function be continuous, a continuous function on, and I did bracket a comma b bracket, this is denoting that it is a closed interval. So it's kind of redundant to say the words closed interval when we use this notation, but when you're first starting to look at it, it's just always good to be reminded that that's what we have. Now, when you have those conditions met, then your function attains an absolute maximum output value. So there's a highest value of the y output that it will attain for some value of x in that interval, and it will also attain an absolute min for some value of x in that interval. So there's a lowest function value as well as a highest function value that we're guaranteed to have on the closed interval when we have a continuous function. Now, we said that we would have an absolute max function value and an absolute min function value on a closed interval for a continuous function, but we didn't say how to find it. Here's how you actually go through the process in order to find it. So to find your absolute maximum and absolute minimum value of a continuous function f of x on a closed interval from a to b, you first find the critical values of the function. And the critical values of a function, we want to be specifically the critical values in that closed interval from a to b. Now remember, critical values of a function are values in the domain of the original function for which the first derivative either comes out zero or the first derivative is undefined. So that sets up our critical values. When we find all the values that are critical values, we again just want to focus on the ones that are in our interval in our question. Then next, you evaluate the original function at each of those critical values that are in the interval. And then in step 3, you evaluate the function at each of the endpoints of your interval. And then in step 4, you just compare those outputs. The output that is the biggest number is your absolute max of your function, and the x that created it is where that maximum occurs. And then the very smallest number of all of the outputs between your step 2 and step 3 is your absolute min, and the x that you ran through in order to get out that absolute minimum value is where it occurs. So take time to write down these steps.